example. Let's say prediction. A very classic example is that someone can simply have a machine learning model that can predict the price of, let's say, stock market. It's actually not that doable right now, but let's just make that example. So how can machines start to predict the stock market? And what people do is people to put historical data in. So for example, I told the machine that yesterday Apple's price is $10. The day before that, it was $9. Even before that, that's $7. The machine can kind of know there is somehow a pattern, linear growth pattern in there. So they will predict the price for tomorrow will be $11. Even though the case in the real world is much more complex, but that's the case, like how machine is learning through the data. It is very easy to understand if you've learned statistics before. So basically, that's based on statistics information and predict the best fit line for your model. And then you will be able to go through all those information after you gather them and use them. Classification is another very classic example for machine learning. As you can do any classification task. For example, if you have remember, you write hand writes from 1 through 9. Let's say I write down 1, 2, 3, 4, and if you put camera on, it can detect it is 1, 2, or 3. So this is actually very classic example, and I can find you some pictures with it, and just hold on to it. Hold on a second, I was trying to find a picture. So here we have the database. It's called MNIST database. And in this database, machine collects all sorts of handwriting style from number 0 to 9. And then they start to recognize that if you're on a whiteboard and only things happen right in the center of the screen, that will probably be 1. Because in any other cases, if, for example, 0, there will be ink around the page instead of right at the center of the page. So that's kind of the intuitive way to understand machine. So machine does not know any prior knowledge. They only know in this white graph, if something happened in the middle, there's 50% chance it's 1, 50% chance it's 2. I'm just making that up, but that's how machines think and how machine learn. So once you put 1 in and they recognize something is in the space and they said it's 1, that's correct. Okay, they got a correct feedback. However, if you got wrong feedback, they will fix their learning. They will fix the idea that they will be in the center. So they will assume maybe 1 can be diagonalized, maybe invert. So they will try to create more theory about, or we call it hypothesis, about their prediction and learning process. Let's go back to our slides. Does anyone have any question? I heard someone, but there seems no question. Okay, good. Then I will go through a very easily visualization model of prediction price. So on the x-axis is this whole background is that you are trying to predict the price of a household. So let's say all the triangle are sample points. So if I say I know there's a house 500 square feet and that can cost 100K, and another household is 1,000 feet square and that only costs 50K, and all those triangles are sample points that you are feeding to the machine. So the machine will understand, okay, those data are coming to me, and I know if you ask me what will the price be for 2,205 square feet house, which is exactly the point. But if I ask the machine, what will be the price for 1,200? There's no sample point here. Then the machine will have the fit line right here. They will start to trying to figure out, okay, based on the overall trend, they might be similar to here. How can they adjust their hypothesis? They adjust this through a cost function. It might look very complicated, but it's very easy to understand. It's just the sum of all differences. So this is considered of differences. It's between the actual data point and the prediction. So they're trying to minimize the error, which is the distance between the actual distance and the predicted price. So after several rounds, if I start off saying I have a line like this, oops, my wrong. Say if starting, I have a series that my model will predict something like this. Okay, then it will find error is pretty large because say if this is the best fit line of this graph, which obviously is not, the error can be defined however. So here, the error is very large. If you can see all those slides, those are errors. And we do not want the actual value and predict value has this large error. So they will try to fix their prediction, maybe linear to this, and this part of error will be minimized, but they will create error on this side. So after iterations, the machine will try to finalize its precision with the point that there's no way they can improve this anymore. So if you change this to this, the error will increase overall. So this is the basic idea for easy understanding of how prediction works in machine learning. And this is if j theta 0, theta 1 is considered of error, the distance between the actual point and the predict point. The highest value should be something like this. It should be pretty high, the error. And something like this should be pretty low. It's here. So we are trying to start at a random point and walk to the lowest point possible. So if I start here, I will go all the way down here. So it's a rather lower point. If I start here, I will not go up, I will go down. So which first hypothesis you give out, or like which best fit line you draw at first, doesn't matter, because you will go all the way down to the smallest value throughout the process. And that's called gradient descent. And that's the most common simple way of doing machine learning. But there's definitely a problem. So say if I started from this point and ends up here, but the actually smallest number is right here. How can we minimize that problem? There are tons of machine learning algorithms available online. So I feel like it will be easier for us to actually do it. And I assume most people here are new to coding and new to machine learning. So I will start off inviting you guys to download Python IDE or use Colab. To make our process easier, I will recommend you use Colab following me the process. I will send the Colab link right here. Chat. So can anyone receive the Colab link in the chat? If yes, please send me something. Okay, great. So if you go to this page for Colab, then you can create something, whatever, randomly. And I will give you guys about 1 to 2 minutes to set up the account, to start and create a new notebook. If you have any question, I think Max will be here to help you with any problem if you have during the setting up the Colab process, and I will be available. So if you cannot set it up, share screen button is on near the camera emoji, and it's around those buttons. You can click share screen and walk near to me. I will be able to assist you throughout this process. And I will continue to share my screen, and we can start off right now. You should probably have this page ready, and we can create a new notebook. Notebook is the way you can run Python code in IPYNB format. Let's see Mega Hack workshop. Okay, starting off, we need to have some basic feature learned for Python, and I assume that will not be a problem for most people, as we are trying to do something easier than that. So let's see. If we're trying to do machine learning, there are several packages we need to learn. The first one is Skylearn, and I will search Skylearn on Google and then introduce you to this special package. It's called Skylearn, and this is a whole package. As I said, gradient descent, all those methods is integrated in this API. You can simply call one thing and get ready for that. I will also share the link of this website in the chat. So let me get back to it. If we're, for example, if we're trying to do a classification task, let's go to the easiest ordinary list square, which is exactly what I've just talking about before. If you remember, minimize all those errors. What we can do is from Skylearn import linear model. So don't feel bad if you are copying code from any website, because that's what you're going to do throughout your workshop, I believe. And once you import this, run this first to make sure that package is included in your Colab environment. If you see the green check here, that will be perfect. If you see the green check here, please type 1 in the chat so I know that. If for some reason you are not able to follow the workshop, it's fine. But I just want to get some feedback if we can go to Colab and import this from the Skylearn package, import the linear model that we just talked about. Okay, I saw someone replied. Good. Okay, all right. So I will move forward. The second step is actually follow this strictly. So let's try to understand what they're trying to do. So basically they said they have a REG. They call that REG because that's regression, because the whole linear model called linear regression. So if we create this, we copy this to our code, we'll create a regressor. So the REG will be able to store any calculation that's done for this. And linear model dot linear regression is calling from here. We're calling from this package, import this model to implement linear regression function. Okay, and then we are trying, let's see what's happening here. Reg fit. So it's just fitting data in. So we have 0, 0, 1, 1, 2, 2, and so 0, 1, 2 large matrix. So what does this mean? Let's try to understand what this means. We fit 3 data in the graph, 0, 0, 1, 1, and 2, 2. And that's exactly what we're trying to do, is trying to give them data, and we want them to produce. We want them to have the regression, linear regression, and we want them to produce the coefficient. So if we run this, we will have two coefficients, is 0.5 and 0.5, which means if you learn some middle school math, it will be 0.5x plus 0.5. So this will be the best fit line for the points that we've given. And that's how linear regression works. Let's get to some more complicated examples. If you're interested in how those data are being processed, how can we manage some larger data like medical data, business data, all those data, please come to our data analysis and visualization workshop that will be hosted by Max later tonight. So I will not go too very deep for this for now, as we will have a data analysis and visualization workshop later. But I will keep trying another example, which let's go to prediction. So for classification is for classify different classes, and regression is for testing different like predictable results. So is there anyone actually wondering how this classification and regression different? They basically did a similar thing, but classification did one more thing than regression. So let's go to Google Jamboard. I was trying to. I will try to graph something. So this will be the both axes, y and x. Classification will have a function that we call sigmoid function. It looks like this. So if you are any value confidence below 0.5, and you are towards the negative end. And if you are above 0.5, you are above the positive end. So this might look very abstract, or you have no clue what I'm talking about. But this, you will understand this once you start to implement some classification task yourself. And all those resources are available in this website, or rather throughout your hackathon event. If you want to build, let's say, a predictable application, for example, let me come up with an idea. So if you're in the health category, you might come up with an idea that can predict the heart rate of a patient throughout the event. So basically, you might get a data set full of the information of the patient's heart rate information. And you want to base that predict the patient's next day's heart rate. And that you can use predict model right here. That's just one example, and you can do way more than that. So if you are stuck in your, or not even start, if you don't have any idea on how to start it, you can just go through Google. Google will tell you everything. If you Google, say, how to build a predictive model for, let's say, patients, and then skip all the ads and go to one of the links. It will be, if you follow through the link, you will have all those things that you want. So let me try to find one for a tutorial. So for the tutorial, I really recommend towards the data science one. You can basically read through this and then start with importing the library they want, importing the models, and then just put your data in the models. Try to implement all those stuff first, and then go back and learn it again. So that's also the reason why I think Hackathon is a worthwhile attending event, is that you will keep learning throughout your project building phase. You will go and try and fail and go again. And okay, I share about Colab and how can you access Skylearn and how can you just Google and copy the code back to the workshop, or not back to the Colab and make it work. Now, I'm going to share another method to do so. It is not code-based, but that's also recommended. We can use Microsoft Azure service. And share the screen. Let's go to Azure service. So this service is provided by Microsoft. And they actually provide a very, very, very strong machine learning platform that you can basically run every possible data you want. So start off, we can search Microsoft Azure machine learning, and you will be able to redirect to this service. And what I rather recommend to do is to put classic here. I'm not sure if they support this now, but let me try it. Sign in. It will retire. Okay, good. So everyone go to this side. This is not a code-based machine learning platform. I will send out this link as well. This will be discontinued, but it will be fine if we still use it. Let's say if there is showing like classic will retire on the time transition to Azure machine learning, we just press close and that will be fine. And if you want to take a tour, of course you will. So I will just basically go through this with you. You will start a new project, start from new, and remember, what we're trying to do is trying to feed the data to the model. For example, let's say if we're trying to get a data, you can just type in saved data sets because they are providing saved data sets for us to use for free. And just feel free to use them because they have the income prediction. You can basically have it. So let's actually do it myself instead of go through the tutorial. The first step, if you get into this classical page, there is no code required to do so. This is the best Azure Microsoft service that I know that without any code that can work. So first, go to saved datasets, samples. There are tons of samples here. Let's just do let's say breast cancer data. Okay, let's just use this data. Click it, we'll be able to visualize the data. Okay, it provides class, age, size, all those medical informations, and this graph will give us a kind of overview of what kind of age group is it. It basically says teenager, and then a little bit of middle age, and the very last in the older age. So this is kind of overview for all those data. Once you drag it in, you can go through several processes to make your model to run. So we have the model ready, and I just start a mega hack. Go to mega hack workshop, and then start one. That's experiment. Okay, so create new experiment, and then we set breast cancer data, and that's only the first step, is to select your data set. The second step is trying to divide the data up. So you want the machine to learn from the 70% data and then to test using the rest of 30% of data. So why do we want to divide the whole data set up instead of using the 100% of the data for machine to learn? Because you want to test how well the machine learned. say if you do not have any data left, they learn through all those data points you feed to them. You are not able to know whether they are correct, because if they have a perfect model, it works perfectly, and then once you put some random number in and they give you a feedback, you are not able to know if that's correct. But with 70-30 rule, you can split the all data into 70% and 30%. You'll be able to test it after your experiment. So let's see how to do the split data. Split data. So we drag this to split the data, and we put the fraction to about 70%. So it's 0.7. And then we have the data connect to the have the data connect to the splitting process. And then what can we do is to put the data into different model. So we have all the linear model, regression. We have Bayesian, linear regression, or linear regression. Let's just use linear regression. It will be very easy to use. We will feed the data and the linear regression. We'll go through both and then connect them together for running connect them together. And we do the let's do the I should not. We have to go back. Let's try to see how can we put also those data in. We have those data transformation. We don't want this. Please go through every single of them if you're interested, but I'm not it's not that important. We do not introduce feature selection, but actually that's what I recommend to do if you are trying to do a machine learning project in the hackathon. And you can evaluate the model after all the process. Let's see, we have the linear regression. Evaluate the model. We can split the data with the evaluation. Cannot connect this to database. After split the data, I think we need a data validation. Okay, so at this time, for now, we're trying to go through the process. If you got stuck, the best way is to Google. Again, let's go back to Google. Microsoft Azure Machine Learning Classics predict model. So that will happen more than one time throughout your hackathon process. And believe me, you will do exactly the same thing I'm doing here, is to go through Google and watch those videos. So basically they're doing the same things as we did, and let's see what we did wrong there, and we cannot go through there. So they have their data sets and they split the data, and then what they did, they split the data. And then they put the regression, and the key element we're missing is train model. So we can go to find the train model selection, train model. Here we go. Okay, so we can use part of the split data. I want to delete the connection. Delete the connection. We can put the part of split data and the model into train model. So put this two in the train model, it will train the model. And that's exactly what we're missing that I was trying to figure out, but I didn't get the answer from. So throughout this process, we have train model, and the other part of data will be used with the trained data model to evaluate the performance of the model. So there's an arrow here. We need to go to tier, because if you haven't realized this problem, you might realize this problem now. We are just giving them a bunch of data, but we didn't specify which column of data we are trying to predict. And that's a problem because we want to feed them data and ask them to predict one data. So let's see, we predict their age. Okay. So we give them all those other information and ask them to predict the patient's age. This probably will not be able to this probably will not be able to finished actually by human, since human will not be able to think, okay, based on the size of the tumor, the class, all those medical information, how old is the patient? So this is not a common question that we can answer as human being. Hence, we are trying to use all those model to use those information to feed the machine and ask the machine to do this age. Before I process ahead, I would like you to actually go to this site and set up as I did from the data to evaluate model for 5 minutes. So please come to me if you made any problem, or Jason or Max. If not, I just wait for others to finish and come to this stage. It's important that you have this hands-on experience so you will be able to do so. Okay, I assume there is no problem here, and I will go ahead and process. So for training data, we are trying to find which one we want to predict, and we want to predict age, as we said. Okay, age checked. However, we are feeding all the data and then tell them to predict the age. Does it make sense? Or does it make sense if we get rid of the age and then ask it to do the age data? So let's just try this first and see what will happen. Train model evaluation is not working. Let's see why. Because we want to score it before evaluate it. So there are many just small parts that you will not be able to memorize, and you need to check it basically every time. But that's completely fine, as we are keep learning new stuff, and we're just using this for all those information. And we go from scoring the data to actually evaluate the model. Okay, so here we have all those information. Let's try to run it and see what will happen. It's queried and it will start running. So it finished. Let's see the result. Let's see. Evaluation result, visualize. Okay, so here is some feedback for this, like mean absolute value, error, and all those errors. So this means our model is finished and there are some errors. Let's try to understand this more. So we set this up as a web service, so we can access on the website. Let's see, predict web service. It's creating the stuff and trying to arrange everything. Okay, that will be perfect. So throughout this process, if you continue researching, you will find out the way that you can implement this on the app or in a website. So all those in the website, people can type in their medical information and the age will pop up. So all those information is all available online. And I do think they can do way more detailed and thorough explanation than me. So if you're interested in that, of course, go Google and do anything you want. But I just do want to introduce this to you that there's something called machine learning, and you can do it either through code like Colab, through Python like packages like Scaleline, or you can also do so by some web service or like Azure, Amazon, all those companies that provide cloud competition. So basically, that's all about our workshop today about introduction to machine learning. If there's one specifically you want to learn, please send me to the chat. Or if there's something you figure out you want to learn more after you start the hackathon, just let me know anytime, and we can gather back anytime throughout the hackathon event. If you meet any problem, we will be able to help you. So if you have any question, you can walk up to here to ask or type in the question. If not, um, here, if you will have questions, it's right here. Stand up right at the orange speaker position. If not, you can leave. That's the end of the workshop.